Welcome back. We're going to continue our discussion on reactions of aldehydes and ketones. And the first, we've looked at a couple already. And what happens when an aldehyde or ketone reacts with an amine? Okay. Now, just to refresh, I think some of you did not actually get this question right on the exam, despite the fact it's been, explained a few times. I'm not sure what the trouble is. Okay. A primary amine, okay, is nitrogen containing two hydrogens. Does that make sense? Okay. A secondary amine is, of course, there's a bond here, it could be attached to anything, it doesn't matter. But the point here is nitrogen containing two hydrogens is a primary amine. Nitrogen containing one hydrogen is a secondary amine. A tertiary amine is nitrogen containing no hydrogens, but still has the three bonds. And a quaternary amine is nitrogen can only have three bonds, but it can have a fourth bond, provided none of them are hydrogens, okay? They're completely different groups, or something else other than hydrogen, but it must have a positive charge, which is why nitrogen that's quaternary attached to four bonds must have a +1 charge, okay? That's only for a quaternary. I'm going to box this, okay, +1 charge. But so primary amine is amine with two hydrogen, a secondary is one hydrogen, tertiary, no hydrogen. Still all of these contains three bonds. A quaternary is four bonds with a positive charge. It's just that simple. I don't know why some of you, missed out on such an easy question on the exam, even though I gave you complex structures, but the structure doesn't matter. You only focus on the nitrogen. Can I ask you which one is primary or secondary? I don't remember which one. But a few of you did get this one wrong. So it's time, since we are discussing about amines, I think it's time we'll refresh that. So I refreshed it for you. All right. Again, I am not going to dwell too much into the mechanism because I have a couple more reactions where I am going to talk about mechanism, and it's impossible to remember everything. Okay. This is a unique kind of amine because it contains both an amine group and an hydroxy group. So it's known as hydroxyl amine. Okay. Okay. When a hydroxylamine reacts with a ketone, okay, or for that matter, an aldehyde. Here I have both ketones, okay? You could have an aldehyde, but the reaction is the same. What I'm going to do is rewrite, okay, but write this bond here, okay? Sorry, it should have been a little bit more tidy, okay? I have moved this bond here, but wrote this double bond over here. So I can see I can show you what's happening, okay? Now I'm going to react this with, I'm going to rewrite this H2 NH2OH as this way. It's the same thing. Okay. I have done nothing. Nothing has changed. Okay. I just wrote the molecule in a different way so I can show you what's happening. Basically, you're removing this water molecule, the oxygen from the starting material and the hydrogen, two hydrogens from the hydroxylamine. So essentially what you're going to end up with is you write everything the same way, but this time write the NOH. Basically, you have coupled the nitrogen to this double bond where it was. So this is the product. And you guessed what would be the product for this. It's the same thing. So again, you're going to combine this with, I'm going to write it this way. So NH2, write it this way. So we know that the O and the hydrogen comes off, which leaves you with There is something called an enamine, which we're gonna, if time permits, I'll make a separate video on it. Okay, so whenever a primary amine like NH2 reacts with a double bond O, basically you get rid of water plus H2O plus H2O and attach the nitrogen directly to the double bond. In this case, you attach the NOH directly to the double bond. In this case, you attach the NCH3 directly to the double bond. And this is reaction addition, nucleophilic addition of aldehydes and ketones with amines. Okay, there's one more that I want to talk about while we are on the topic, and that is Wolff-Kishner. This is again very similar to what we did earlier, but this is a very unique class of compound. It's called hydrazine. Okay, whenever an aldehyde or a ketone reacts with hydrazine, so this is Wolff-Kishner reagent. This doesn't change. So whenever you see, this is not same as NH2OH. This is NH2NH2. That's called hydrazine. So whenever you see a set of this reagent reacting with an aldehyde or a ketone, all is going to happen here is I am going to write everything the same, okay, except the double bond O. And the double bond O is basically replaced by two hydrogens. Whether it's an aldehyde or ketone, it doesn't matter. Whenever you have a Wolff-Kishner reaction where you're adding a hydrazine and KOH, this is a set, okay? This is Wolff-Kishner's reagent. You go from an aldehyde to, basically replace, again, same with the ketone. It doesn't matter whether it's an aldehyde or ketone, you're going to get the same product. So, I mean, not same product, but you kind of get the same drift, okay? So you write everything the same and replace the double bond O with. In fact, this is one of the favorite reactions of my students because they just can't get it wrong. If you get this one wrong on a test or a quiz or homework, I don't know what else you would get right because this is the easiest of the bunch. Okay, this is Wolff-Kishner. Again, this is along the lines of an amine reacting with an aldehyde or a ketone. Okay, so I think I only have a couple more reactions to show, but I'm going to stop this video here, and then we have a couple more reactions to look at, and then we'll be done with nucleophilic addition reactions. All right, so stay tuned.